Okay, folks, this is my first try at this, so give me a break here, all right? This is covering section 3.3 called Polynomial Division. The first thing we're going to talk about is something called monomial division, which you've seen already in algebra, and the concept is really easy. If you're dividing by a monomial, like negative 2x squared, all you do is split the polynomial up into consecutive divisions. So we would look at this as 8x to the fourth divided by negative 2x. Minus 2x cubed divided by negative 2x plus 12x squared divided by negative 2x, and then minus 10 divided by negative 2x. And then perform each division using your rules for powers. So negative 8, or 8 divided by negative 2 is negative 4, but x to the fourth divided by x, notice we have a power of 4, the power of 1 is implied, so 4 minus 1 is 3, so that's negative 4x cubed. Then the two negatives make a positive over here, and this is just going to be x squared because the 2's canceled. Then we have a positive and a negative, so that's minus 6x, and then two negatives give us plus 5 over x. Okay, so you should remember that and be able to get through those problems really easy. The next type, though, in our regular division or polynomial division is based on your division algorithm from back in middle school, okay? So remember, when you divided something like 202 divided by 5, you should have learned a division algorithm where you wrote this as 202 and that division operator divided by 5, right? Now, you're looking for how many times 5 goes into 20, because it doesn't go into 2 evenly. So 5 goes into 24 times, so you put the 4 here, 5 times 4 is 20. And then when you subtract, you bring down these cancel, and you bring down your 2. Now 5 won't go into 2, so that's called the remainder, right? So you fill this spot with a 0. So your quotient is 40, but you have a remainder of 2. So what that means is 5 times 40 plus 2 is your number that you started with, 202, okay? Recall that the 202 is called the dividend, the 5 is called the divisor, and the 40 is the quotient. And of course, the 2 is the remainder, all right? Well, division of polynomials is analogous to this. It's pretty much the same process, okay? Now, on the next slide here, I have the official mathematical definition, which we all know sometimes seems a lot more complicated than it really is. So we'll talk a little bit about this more in class, but this is just saying if you take a polynomial f of x, the dividend, divide it by another polynomial d of x, the divisor, you get the quotient plus the remainder. And then, of course, to check this, the divisor times the quotient plus the remainder is equal to the original polynomial that you start with. We'll talk more about the definition in class later. Okay, so I want to go through a couple of these problems and show you exactly what's happening here. The first example, remember, we're dividing this polynomial, so that's our dividend, and we're dividing it by this, which is our divisor. Okay, so it's similar here. Watch, we're just going to put the dividend, 6x squared plus 13x minus 5, and we're going to divide that by the 3x minus 1. Okay? And then we're going to repeat this process, but now notice we've got two terms here. We've got the 3x and the 1. Okay, so it's going to be a little bit different. Now, you're still looking for something that you can multiply 3x by to give you this value here of 6x squared. Okay? And notice that's 2x. So if we put our 2x up here in the first slot of our quotient, and then we take 2x times 3x to get our 6x squared, right? But then we have to take the 2x times the negative 1. That's negative 2x, so we'll collect it under its like term and write it under the 13x. And then just like in our division algorithm, we're going to divide here, okay? So we're dividing. The next step in our algorithm is to subtract these terms. So notice this is always going to be 0 here in the first column because 6x squared minus 6x squared is 0. Be careful here, this is a subtraction, so 13x squared minus negative 2x is a positive 15x. And then bring down the minus 5. And we're going to repeat that process again. Okay, so Now we're looking for something we multiply this first term again here, the 3x, by something to get 15x. Notice that that is a positive 5, okay? So then we multiply through again. 5 times 3x is 15x, and 5 times negative 1 is negative 5. And of course, we always subtract after we do that multiplication. Notice this is 0, so our remainder is 0. Okay? It's possible that you have a remainder of 0. It's possible that your remainder is some other polynomial other than 0. Okay? Now, what that means is, to check this problem, we can go over here and we can take our dividend, which was, we're looking for the 6x squared plus 13x minus 5, right? So that should be equal to that 3x minus 1, which was our divisor, right? Times our quotient here of 2x plus 5. So if we take this 3x minus 1 times the 2x plus 5 and multiply them together, we should get this dividend that we started with. And notice if you FOIL this out, you do get this here. Okay, so that's how you would check to make sure that that works. So our answer to this division problem then is 2x plus 5. So there's our solution. Okay? But if you notice, it's very similar to our algorithm when we used real numbers here in this slide. Okay, one thing that does come up occasionally is you have to do what's called zero filling in your dividend. Notice when we're dividing this, we have 2x to the 4th minus 8x cubed, but there's a missing x squared and a missing x power. So we're going to put in 0x squared, 0x, and then the 12, okay? Those are just going to be placeholders to collect our terms when we start our algorithm here. Then we're going to divide that by the x squared minus 2, okay? So once again, we look and see what do we need to multiply x squared by to get 2x to the 4th? Well, that's just 2x squared, right? So 2x squared times x squared is 2x to the 4th. And then 2x squared times negative 2 is negative 4x squared. Notice we've got to move that over here underneath our x squared term because we can't combine it with our x cubed. That's why we zero filled here. Then we subtract. These always cancel. We just bring the negative 8x cubed down. But remember, this is a subtraction of this row. So when you subtract negative 4 from 0, you get a positive 4x squared. Then bring the other terms down that are left over on the right-hand side here. Repeat the process till we can't anymore. So then we're going to take this x squared. We need to multiply that by a negative 8x to get the negative 8x cubed. So that's negative 8x next, right? And then when we take negative 8x times x squared, we get negative 8x cubed. All right, and then negative 8x times negative 2 is a positive 16x. So remember, we have to collect that over our like term, so that's the plus 16x here. And then, of course, we do subtract. Bringing our terms down again, we're going to bring down the 4x squared. Then we have, remember, this is a subtraction, so we have a minus 16x. We're subtracting this row, and then bring down the plus 12. We can do this one more time, because if we take x squared times 4, we get 4x squared. So we take a plus 4 here, and then we multiply through again and get 4x squared. And then that's a minus 8 here. Notice we put it under our constant 12, okay? Then when we subtract, we get negative 16x plus 20. Remember, once again, that's a subtraction. Notice now that you can't take the x squared by anything to get a lower power of x. Remember, you're not allowed to have negative powers in your polynomials. So we have to stop there, and this is our remainder, okay? So our solution to this is the quotient plus the remainder. So since our remainder is negative 16x plus 20, we write that here's our solution. It's this minus 16x plus 20. Okay? There's a couple other ways that you can write the remainder. However, we're just going to leave it like that for now. Okay, now I'm going to leave you to check this one, to maybe practice your multiplication, but I'll set the checkup for you here. Okay. So remember, the check is the quotient times the divisor plus the remainder. So for our check here on this problem, we're going to take quotient times divisor plus remainder. All right, so here's the check. Let me move this down and give myself a little more room here. So we had 2x squared minus 8x plus 4 times the divisor, which was x squared minus 2, and then plus the remainder, so that's minus 16x plus 20. Now when you multiply that out and then add in the remainder here, you should come up with our original dividend of 2x to the 4th minus 8x cubed plus 12. That's pretty much it for polynomial division. I've got a few blank slides here. I'm going to leave you practice a couple of these before you come to class, and then make sure you bring questions if you have any. If you need to go back and watch this video a few times, go ahead and just watch the steps if you need to kind of go through the motions a few times. So here's a problem for you to work on. This is dividing fourth power by a second degree polynomial, okay? Now, don't let the three terms in the divisor confuse you. Your divisor can have as many terms as possible, all right? You just keep repeating your process here. And then how about one more here? And remember, division can be written this way also. So if it's written in this form, this is the same as 3x to the 4th minus 7x cubed. Don't forget to zero fill your x squared and your x plus 5. And then you're dividing that by x squared plus 2. And notice you never zero fill in your divisor. It gets really messy if you do it that way. You can, it won't hurt anything, but you'll see what I mean if you accidentally do that. So never zero fill on the divisor. Only zero fill in your dividend here for the missing powers, okay? Good luck, and we'll see you in class.